You know how some people seem like math wizards? They can just spit out answers to tricky calculations like it's nothing? Well, today, we're going to pull back the curtain on one of their secrets. And trust me, it's way easier than you think. All right, let's put you on the spot. Quick, what's 85 times 85? Go ahead, try to figure it out in your head. No calculators. It's a bit of a mental workout, right? Boom, the answer is 7225. Now, if you got that in just a couple of seconds, you're probably already in on the secret. For the rest of us, the first question is probably, how on earth can someone do that so fast when most of us are still trying to remember how to do long multiplication on paper? Well, it's not magic. It's actually a really elegant, ancient technique. The secret has a name, Ikadikana. It comes from a system of math from ancient India called Vedic mathematics, which is just packed with these amazing little shortcuts. They call them sutras for flying through problems. The full name is Ekadikana Purvanya, which literally translates to by one more than the previous one. And get this, that little phrase, that's the entire instruction manual. Seriously. Okay, so let's break this down. We're going to start with a super simple example to see how it works. Squaring the number 25. This is a classic one. Ready? Here we go. Step 1. You look at the number that comes before the 5. In 25, that's the 2. Step 2. Add 1 to that number. So 2 plus 1 is 3. Easy. Step 3. Multiply the original number, 2, by that new number, 3. That gives you 6. And the final step? You just tack 25 onto the end. And just like that, 25 squared is 625. No complicated math, just a couple of simple little steps. Pretty cool, right? Once you see it, it's kind of hard to unsee how simple it is. Okay. That was easy enough for 25. But you might be wondering, does this little trick hold up when the numbers get bigger? Let's find out. Let's try 65 squared. The rules are exactly the same. So go on, try it in your head right now using those steps we just learned. I'll give you a second. Did you get it? Let's check. The number previous to the 5 is 6. 1 more than 6 is 7. You multiply those together, 6 times 7 is 42. Then you just put 25 at the end. The answer is 4225. Yep, works like a charm. And this thing isn't just for two-digit numbers. Oh no, take a look at 105 squared. The previous part is 10. 1 more than that is 11. What's 10 times 11? It's 110. Slap a 25 on the end and you get 11,025. It just keeps working. I mean, this table just lays it all out perfectly, doesn't it? You can really see the pattern in action. You just take the number before the 5, multiply it by the next whole number, and you've got the first part of your answer. The second part is always 25. Look at 135 squared. All you need to know is that 13 times 14 is 182, and boom, the answer, 182.25, just falls right into place. So this feels like a magic trick, but it's not. It's actually built on a rock-solid mathematical foundation. So now let's peek behind the curtain and see the elegant algebra that makes this whole thing tick. So let's think like a mathematician for just a second. I promise it's not scary. Any number that ends in 5 can be written out as 10a plus 5. A is just whatever number comes before the 5. So for 25, a is 2. For 65, a is 6. You get the idea. It's just a way to describe all these numbers at once. So if we want to square one of these numbers, what we're really doing, algebraically, is calculating 10a plus 5 squared. And this is where the magic gets explained by cold, hard logic. And here it is, the big reveal. When you expand 10a plus 5 squared, it simplifies to this formula. And look closely, there is our trick. See the a times a plus 1? That's us multiplying the previous number by 1 more than the previous one. The 100 just shifts that result over 2 places, leaving perfect room for the plus 25 at the end. That formula right there is the trick. And, this isn't just some random one-off thing. As this quote says, it's part of a whole system designed to make math faster and easier. It just goes to show you how looking at a problem from a different angle can make it so much more intuitive. So it leaves you with a pretty big question, doesn't it? If a simple idea from an ancient text can hide such a clever and powerful shortcut for math, it really makes you wonder, what other brilliant ideas have we forgotten? What else is out there just waiting to be rediscovered?